Hello everyone. Today we will discuss about the motion of a vehicle on a level circular road. Very interesting topic. So for that we need to consider a circular road, right? So this is our circular road. This is the center of this circular road and let's draw our car. Okay. So this car is moving on this circular road. So this car is moving like this. So if you look at the car from this side, obviously these will be your headlights which will be visible from the back side. Headlights, sorry, backlights, tail lights. So these are the tail lights, right? Now this is the radius of this circular path, right? And when you are taking a turn, you know that there is some force which is outside this circular path. So that's why in order to oppose that outward movement of the tires, there is some force which is acting parallel to the tires in the opposite direction, that is your friction force. So I would like to draw a bigger diagram here for more clarity. So this is the car, okay, and what all forces are acting on it, we need to mark those forces first. This is the weight of the car which is acting downward, the normal reaction which is acting normally outward to the surface on which it is placed, the friction force which we have just discussed here, right? So which force is holding this car towards a particular center so that the car can take a turn on this circular path? Friction force is holding it towards the center. So that means friction force is providing the centripetal force for the circular motion of the car. You know what is centripetal force? Centripetal force is the force required for the circular motion of a car. So that's why we can say that friction force is providing the centripetal force here. So we need to mention it. Friction force provides the centripetal force for circular motion. Right? Now you tell me, if you have 100 rupees and your friend is in requirement of 70 rupees. So in what condition are you able to give him 70 rupees? That means even if you have 70 rupees, you are in a position to fulfill your friend's need. But if you have 100 rupees, it's fine. Then also you are in a position to fulfill the need of your friend. So that means the provider must be greater than or equal to. Now here friction force is the provider for centripetal force. So that's why we can write that this centripetal force must be greater than or equal to this centripetal force, right? So what is the formula for friction force? We know that friction force is equal to mu s into normal reaction. Here I am denoting normal reaction by R. Now this I can put in this equation. This is first, this is second, and also we know that centripetal force is equal to mv square upon r, where r is the radius of the circular path. So this is our equation 3. Now I can put these values in one, put 2 and 3 in 1. So what will I get? Mu s r is greater than equal to mv square upon r. Now look at this. Is the car flying in the air? No. So that means the vertical forces are balancing. So I can write that normal reaction is balancing the weight of the car. So therefore, our expression 4 becomes from 5 in 4, I can write mu s mg is greater than equal to mv square upon r. If I solve it, I'll get this, that v square is less than equal to mu rg. So v is less than equal to under root of mu rg. So some important points from this expression, and what are those important points? Let's check that. So here the important points I'm marking. This is first thing, V is directly proportional to under root of mu s, means more friction, more velocity, more speed of the car on the level circular road. Second thing, if friction is more, we all know that if friction is more, there is more wastage of energy. So therefore wear and tear of tires is more. So you can say friction is more, there will be more wear and tear of tires. And also for this thing, if r is less, the velocity is less. If r is more, the velocity is more. But we know whatever circular roads are there, we want the velocity to be maximum without much wear and tear of the tires. So there is a solution for this problem, which is called as banking of roads, which we will study in the next video. So that's all for today. Thank you and have a nice day.